Hello class, and welcome back to another lesson, and our last lesson for probability. So with all the calculations that you've done, now we're going to talk about if you're given some data, some information, how do we interpret that? How can we take that probability that we've been working on in fractions, use it as a decimal, as a percent, and then use it to help us predict other information. So at the top here it says probability and statistics are presented through the media in a variety of contexts. Statistics is the collection and analysis of numerical data. That's going to be our next unit. And it's used to help predict the result of future events. Statistics involves collecting data from real-life events or studies. And data is the facts or pieces of information that are analyzed to create statistics. So example 1 here, we're going to do part of it together, and I'm going to have you, for your homework, try some of the parts of it out on your own. So a movie theater surveyed 300 moviegoers to determine their favorite movie genre. The results are shown in this table below. Part A says, express the frequency of each movie genre as a fraction in lowest terms, a decimal, and a percent. So we're going to do an example with comedy together, and then I'm going to get you to do drama, romantic comedy, horror, and documentary on your own, and then you can check your answers later. So if I want to know the probability that someone liked comedy, then we're going to say probability of, I'll put C for comedy, is 95 people over our total. And if we can see here, our total within the question is 300. So that part we know already, and I think you guys are getting really good at that so far. So if we do 95 divided by 300, we can divide both of them by 5. Let's do that here, because obviously that's not our lowest fraction. It's not wrong, but it's not the lowest. And we'll get 19 out of 60. Awesome. Okay, so that's our fraction part done, but what about as a decimal? Well, the easiest part to do that, to get that answer, is to do our numerator divided by our denominator. Or we'll do 19 divided by 60. So you're going to do that in your calculator. 19 divided by 60. And you should get a decimal, which is 0.31. Let's do 2 more. Through 6. And if you can see, there's 6s forever. So we're going to round up and say 7. So 0.3167 is our decimal. And lastly, to get to our final answer, which is turning it into a percent, we're going to take that decimal and times it by 100. So if we do that, then you end up getting 31.67%. So about 31%, almost 32% of people said that their favorite movie genre is comedy. So I want you to try that for drama, romantic comedy, horror, and documentary. Tell me the fraction, tell me the decimal, and the percentage. And on our calendar, you'll see a spot for the solutions, and you can check your answer. So the next question says, if there was a total of 5,000 people instead of 300 who saw a movie the day the survey occurred, how many of them would you expect to pick comedy as their favorite genre? How many would pick drama, rom-com, horror, documentary? So now that we know that there's I'm going to highlight this with a different color here, 31.67% chance, or 0.3167, it's really easy to take that number that you got and apply it to a different number. So if we expected 5,000 people to come to the theater, we're going to multiply that by our percent, so 0.3167. If you multiply it by the percentage number over here, then you're going to get a huge number, right? We always want to take that percent and turn it into a decimal, except we already did the decimal. So it's right here. So we take our new total and we multiply it by the decimal, and that should give us the actual number of people that we would expect, based on these results, to like comedy. So if we do that, 5,000 times 0.3167, then we get an answer of 1583.5. Except that doesn't really make sense, that you can have a half a person. So we're just going to ignore that and say about 1,583 people would probably say that comedy was their favorite, as an estimation. So I want you to do that the same thing that we did in part B as well for drama, romantic comedy, horror, and documentary. So that's kind of part of your work for today. Let's try example 2. So now we can kind of take this and turn it into what if we can apply statistics and probability to sports, right? Because that's another application of probability in real life. Professional sports teams keep statistics on all players. This helps to predict how each player will perform. For every 232 shots, Jason Spezza scores 34 goals, and for every 303 shots, Alexander Ovechkin scores 38 goals. What are their successful shooting percentages? So let's take Jason Spezza. I just put it as initials here. We know that he has 34 goals for every 232 shots. So you're going to take that 34, divide it by 232, multiply by 100, and you're going to get 14.66%. I'm going to put that in brackets how we did that. So again, you take the top 34 divided by 232 and then multiply that by 100 to get your percent. We're going to do the same thing for Alexander Ovechkin, and we're going to say that he is 38 out of 303. So again, you do the top divided by the bottom times 100. 38 divided by 303 times 100, and we get 12.54%. So if they were playing each other, who would you expect to score first? That means based on the probabilities, what would you expect? Jason is 14.66%, Ovechkin is 12.54%, so we're going to assume that the higher percentage means they're more likely to score first. Is it a big percentage? No, but it still counts. So there's 2 more questions left, and since we've done 2 examples together, what I would like you to do, actually this one doesn't have an A, is try these on your own. So you can pause the video and then, keep it here while you try out the question, and same with the following question, and then I will post the solutions on our Google Classroom, and then you'll be able to check out your answers and see how you're doing. That's pretty much the plan for this week, is just finish up probability. So this question, we'll read it together, then I'll flip to the next one. During the month of April 2006, a long time ago, at least some rainfall was recorded on 12 different days at the Sarnia Airport weather station. Suppose one day in April 2006 is selected at random. What is the probability of choosing a day that it rained? And lastly, another sports question. In the 2012 season, Derek Jeter of the New York Yankees had 683 at-bats. He made 216 hits and scored 99 runs. What was his hitting average? Express your answer as a fraction, decimal, and percentage. So hitting average is like how many hits, like how many times did he make contact with the ball out of his total times that he went up to bat. B is what percentage of his hits resulted in a run. And so that means out of the total number of hits, how many were a run. And lastly, you're going to try and use these 2 percentages that you found to answer the third question. In his major league career, Derek Jeter has had 10,551 at-bats, which means that's how many times he's gone up to bat. What percentage of at-bats occurred during the 2012 season? All right, so try that out and check your answers later.